Graphing cotangent is actually going to be a little bit more friendly than graphing tangent. See, cotangent's asymptotes are at the pi's. So it's going to be at 0 pi, and then at 1 pi, and then at 2 pi, and so on. And then what happens with cotangent is cotangent crosses right halfway in between the asymptotes on the axis. And then just like tangent, halfway in between are going to be those values that go up to 1 and -1. But now cotangent is going to actually be going down. So when we graph those points of going up to 1 and down to -1, you're going to see that the S kind of goes down, hugs the asymptote. On this side it's going up. Okay, so this is kind of the general look of cotangent. It looks a lot like tangent, it's just flipped so that it's going down instead of going up. And the asymptotes are shifted over a little bit. In fact, the way you find the asymptote is by taking b times x plus c. So that whole thing after the cotangent, it's going to have all this stuff with the period and the phase shift and all that. And that's going to equal n pi. It's not going to have that 2 pi n plus pi over 2 thing that we had before. It's just that n pi. So it makes it actually quite a lot easier, a little bit more user-friendly. So if we look at an example, let's just look at finding the asymptotes on this one. So let's say I have y equals 2 cotangent of 3 times x minus pi over 2 plus 4. And I want to find the asymptotes. So I'm going to take just this part right here. I don't care about the 2, I don't care about the 4, I just care about that part times x, the b value and the c value. Those are really the only parts I care about. So I'm going to take those, and so I have 3 times x minus pi over 2 equals, and then I set that equal to n pi. Remember, n is which asymptote we're on, so we'll deal with that later. Now it's a matter of solving for x. So I've got to get rid of 3, I divide by 3 on both sides. So now I have x minus pi over 2 equals n pi over 3. And then I'm going to add pi over 2 to both sides. So now we have x equals n pi over 3 plus pi over 2. Now we actually have to find out what is it when I plug in 0, what is it when I plug in 1, what is it when I plug in 2. But before I do that, I think it's best actually just to get a common denominator right off the bat, because it's obvious we're going to need one because we're adding 2 fractions with different denominators. So I'll multiply by 2 on that one. I'll multiply by 3 on that one. So now we have 2n pi plus 3 pi all over the same denominator of 6. So then when I'm plugging in different n values, so let's just do n equals -1, n equals 0, and n equals 1. Of course, you can pick 0, 1, 2, whatever makes sense. But don't pick them too crazy, just because then they get really big and far away from where you're trying to graph. And so if I plug these in, so now what I'm going to do is I'm going to take -1, I'm going to plug it in for n, so that gives me -2 pi plus 3 pi, that just gives me 1 pi over 6. And then I'm going to plug in 0, so I plug in 0 here, this cancels out, so I just get 3 pi over 6, which reduces to pi over 2. And then we plug in 1, that gives me 5 pi over 6. Okay, and then we would go ahead and graph. So that's one example of a cotangent. Let's actually do a full graphing. So y equals, let's do 2 cotangent of 2 times x plus pi over 4 minus 1. All right. So we go through and we say our amplitude is 2. The period, remember the period for cotangent and tangent are both pi. So now we're just going to take pi divided by the b value, which is 2. I'm not going to worry about width of the quarters on here because, if we did it, we're just taking pi over 2 and we're multiplying it by 1/4. But really, because of our asymptote work, we don't have to do this. Our phase shift, again, we don't really have to do this, but we'll put it down, pi over 4 to the left. And then our vertical shift is 1 down. Okay, now for our asymptote work. So we have to work all that out. So let's see, we have 2 times x plus pi over 4 equals n pi, divide by 2. So now x plus pi over 4 equals and pi over 2. And then we'll subtract pi over 4 from both sides, so that's gone now. And then I need a common denominator. So that'd be 2 pi over 4 minus pi over 4. Sorry, there's an n in there. So now, for my asymptotes, let's just do -1, 0, and 1. If we plug in -1, we will get -3 pi over 4. If we plug in 0, we'll get negative pi over 4. And if we plug in 1, we'll get pi over 4. Okay, so now when we graph, we have to make sure that we think about this, that we have coupled in the negatives. So we're going to have our x-axis more to the left of the y-axis. Amplitude is 2, vertical shift is 1. So let's see here. Let's graph. Let's go something like that. Let's see, let's label our axes. So we have, let's see, pi over 4 here. And then we need one at negative pi over 4. And we need one at negative 3 pi over 4. Put in the axes. Okay, I'm going to need my vertical shift of 1 down. That'd be a -1, so we put in the dots there. And my amplitude is 2, so I go up 1, 2, I'm going to be at 1. Go down 2, be at -3. Okay. Halfways, we have those already marked, and so now we can graph. I'll do that in blue. So this is cotangent, halfway in between, we cross the axis. You want to make sure that the axis is actually halfway between, and here it is. All right, now halfway in between those guys, we have, let's see, amplitude of 2, or that's not really technically an amplitude, but okay. And then we graph in the cotangent. And there it is. All right, good luck.